Hey, hello. Welcome back to another Math Counts Me. Today we're continuing 2013 Nationals. We're on number 24 sprint. If A and B are real numbers such that A plus B equals 1 and A squared plus B squared equals 2, what is the value of A cubed plus B cubed? Express your answer as a common fraction. Okay, so this is like this problem is a common type of problem that shows up in like AMC and math counts and stuff. And it's basically like you're given some parts of a plus b, a squared plus b squared, a b, a cube plus b cube, and maybe some other stuff. And you want to find like one or the other or something. And how you do it is you can like square a plus b and then subtract ab, and this equals a squared plus b squared. And then you can cube a plus b, and this would be equal to a cubed plus b cubed plus 3 a squared b plus 3 a b squared, which is a cubed plus b cubed plus 3 ab a plus b. So then you could say a plus b cubed minus 3ab a plus b, and these are all in this set thing. You could say this is equal to a cubed plus b cubed. Okay, so like in this one, what we can do is we can square a plus b, and oh, you need to subtract 2ab. That's my bad. Okay, so if we subtract 2ab from a plus b squared, then we get a squared plus b squared. And this is just from like expanding a plus b out, right? A plus b squared is just a squared plus b squared plus 2ab. So this is obviously correct. Okay. Now, in our problem, we have a plus b and a squared plus b squared. So we can use this to solve for ab. So then we have 1 minus 2ab equals 2. So negative 2ab equals 1. So ab equals negative 1 half. Okay. And then this is good because we can use this in our a plus b cubed formula thing. So we can say, a plus b cubed is a cubed plus b cubed plus 3ab a plus b. Just get this from expanding a plus b cubed. And then, okay, so we want to find a cubed plus b cubed, and we just solved ab, and we have a plus b as a given. So now we can just solve it. So yeah, just plug it in now. And then we have 1 plus 3 halves is a cubed plus b cubed. So then it equals 5 halves. And yeah, that's the answer, 5 halves. Anything you want to say there, Bo?
Right, like Austin said, this is something that comes up a lot. Something like this. So just know that, like, I guess squaring them or cubing
Just
them.
yeah, just realize you can do. I mean, all you have to like, um, all you have to do really is just to like square and cube the a plus b, and then just work with it.
Mhm.
Um, there's also a variation of this where like you have like x plus 1 over x and x plus or x x squared plus 1 over x squared, right? This comes up sometimes, maybe. and you have like x cubed plus 1 over x cubed and stuff.
Yeah,
But I mean, just in this thing, you just do the same thing with like
right. Because I
squaring
mean, in
it.
this case, it's just you can just say like 1/x is equal to like b or something. Is b and x is a. It's like same thing happens basically.
Yeah, and also some terms will like cancel out to be
Yeah.
constants. Yeah.
Sometimes like x and 1/x they'll cancel out.
Yeah. Okay. How many times in a 24-hour day will the hour and minute hands of a 12-hour analog clock form a 90-degree angle? Okay. Um. So basically, start at 12 a.m. You have both hands here. Okay, and then they're gonna go through the day. So it's gonna go through 2 cycles of hitting 12, right? And we want to find how many times the hour and minute hands will hit to be 90-degree angles. Now we can just separate this into like 2 parts where like one part is 12 a.m. to 12 p.m. and the other part is 12 p.m. to 12 a.m. and they're identical, right? Um, like because the clock has 12 hours and we're looking at a 24-hour period. So we can just look at half the period, which would just be both hands going through 12 hours and coming back to this original position. And then we just double all the right angles that we find. Okay, so let me just write that down so we don't forget it. Okay. And so now we just need to figure out the right angles in this period. And I mean, I would definitely think the best way to do this would be to think about it like analytically instead of or think about it like conceptually and not like algebraically. Like um I'm not sure if this is the best problem to work with like formulas and numbers and stuff. Or that would be really hard, I think. I'm not even sure how you do that. Right, Bill?
Yeah. It will be pretty hard to just to try and do this like numerically. You just want to think of like how the clock hands are like how like their interactions with each other.
Yeah. Yeah, it's much easier to think of it like that. Or it's not that easy, but easier. Okay. So yeah, we're just like gonna think about when all of the times where they make right angles to each other. Now, there are gonna be 2 types of right angles that they can make, right? One where the minute hand is counterclockwise of the hour hand, like that, or one where the hour hand is counterclockwise to the minute hand, like that. And you can consider them both at the same time, but I feel like maybe it's a little bit simpler to just consider one of these at one time. So we can do that. Okay. So let's just consider the minute hand has to be counterclockwise uh to the hour hand. Or 90 degrees counterclockwise to the hour hand. Okay. Okay. So when would that happen? Well, it's not. So okay, it's not happening here. We're starting right here, right on the 12th, both on 12. Okay, and then as we go through time, the minute hand will rotate around this, and once it passes one period, the hour hand will have passed um, one hour mark, right? So the minute hand, when it goes through the entire circle, and it comes back here, the hour hand will be at 1 now, right? Okay, now let's think if through that whole cycle, if a right angle is ever made of this type. So as we go, it's not going to happen there. But as we reach over here, it's gonna happen, right? Because like the hour hand is somewhere here, like in between 1 and 12ish, or more near 1, and then the minute hand is gonna be right here or something, and then this is gonna make a right angle, and the minute hand is counterclockwise of the hour hand, so this fits. So one right angle and only one right angle will be made during the 0th hour, right? Because after this right angle is made, then the minute hand will move faster than the hour hand, and it's gonna pass it, and it's gonna pass the 12 mark before another right angle is made. So this is the only right angle that happens on the 0th hour. Okay, so now we can consider the first hour, right? So we had one right angle on the 12th hour. So we can write that down, I guess, as a tally mark or something. Okay, so now we need to consider the first hour. Okay, so minute hand is there, hour hand is here. And minute hand is just gonna go around again, and hour hand is gonna go to here slowly. And we can see that there's going to be whoops, okay, okay, so we're at the first hour now. So hour hand is at 1 and minute hand is at 12. So minute hand is going to go around all the way to 12, and then hour hand is going to go slowly to 2. And we can see that there's going to be another right angle forming. So the hour hand is going to be somewhere near 2-ish, and the minute hand is going to be near 12. And then this is going to form a right angle right here. And this is also going to be the one and only right angle that is formed during the first hour, right? Because in the beginning, there's not going to be any right angle forming where the minute hand is kind of clockwise with the hour hand. But it's going to form a right angle before it crosses 12. Since when it crosses 12, there's a smaller angle, right? So it's like it has a bigger angle and it's decreasing. So at some point, it must hit a right angle. So we're also going to have one right angle in the first hour. So it seems like we're going to have one right angle in every hour, but you have to be careful on that because on the third hour, okay, so we just looked at the second hour. So now consider consider we're at this position and consider the right angle. Okay, so we're gonna go the minute hand is gonna go through this clock, and then this hour hand is gonna go from 2 to 3. Now, when is it gonna make a right angle? It's gonna make a right angle when the hour hand is at 3 and the minute hand is back at 12, right? And this makes a right angle, but this is like on the third hour. So so then the second hour doesn't have any right angles made, and this is instead the third hour's right angle. So so we count 1 for a right angle made on the third hour, but we had no right angle made on the second hour because when we made the right angle, it went to the next hour. Okay, and then on the third hour, we're not gonna have any more right angles because this angle from as it moves from 12 to 3, it's gonna get smaller, and then as it goes beyond that, it's gonna get larger and larger, and we're not gonna hit another 90-degree angle until this minute hand crosses 12 again. So basically, the two like skipped a right angle because when its right angle hit, it went to the third hour. I hope that makes sense. Okay, and then you should be able to see that from every hour onwards from now, you're always going to have one right angle. So like, okay, so we had one right angle on the third hour. If we consider the fourth hour, we're gonna make a right angle pretty soon, like somewhere here. And then as we make this, there's gonna be no right angle all the way through there, right? And then we need to hit the fifth hour. So basically you can think of the right angle thing like precessing, right? So first it's here, and then it's gonna be like here for the fourth hour, and it's only gonna be made once. And then the fifth hour, it's not down there. It's like right here, okay. And then the fifth hour, the right angle is gonna be like here, and then it's just and then you just have it like keep on turning. So on the sixth hour, the right angle will be right here. We have no problems with that, and all the hours are gonna have one right angle like this, and it's just gonna keep on going, and then we should consider the last few hours to see if there are any problems with that. So on the 11th hour, let's just have it start at 11 and minute hand is at 12. Okay, and we want the minute hand to be 90 degrees counterclockwise of the hour hand. And then we can see that this is going to happen somewhere where the hour hand is here and the minute hand is here. Okay. And then after this, it's going to go to the 12th hour, and no more right angles is going to be made, right? So one right angle will be made on the 11th hour, and then as it reaches the 12th hour, no more right angles will be made. Okay, just like only one right angle is going to be made on the 11th hour, so no problems with that there. And then as it hits 12, we can just double all of our right angles for the next 12 hours, right? Okay, so we had one right angle for every hour except for the second hour, which we skipped. So then that's going to be 11 right angles for that. And we're going to double it for the next 12 hours. So then we're going to have 22. But now we also have to consider this type of right angle with the hour hand counterclockwise to the minute hand. But I mean, you can kind of see with symmetry that I don't know, but this is gonna be the same thing as what we just did. So like on the 0th hour, okay, minute hand starts here, hour hand is here. Okay, so one right angle is gonna be made, like somewhere here, right? It's like boom and boom. First right angle. Okay, and then as we go through the hours, this is gonna precess. But on the 8th hour, where is it gonna hit the right angle? It's gonna hit the right angle when the hour hand is at 9, and then the minute hand comes back to 12. So it's gonna hit a right angle just when the clock turns 9. So then a right angle is skipped on 8 again. So then you don't have one for 8, and 9's right angle is just this right angle, and 9 will have no other right angles. So this was like the same thing as our other case. So we're also going to have 11 right angles for this, and then we double it to have 22 for the 24-hour period. And then we just add these two together to get 44 in total, which is our answer. I'm not sure how well I explain that, but basically, uh, you can just think of the right angle like processing between hours, and once it processes like a whole cycle, it's gonna skip a right angle. Uh, yeah, I hope that makes sense. Anything you want to say there, Bill?
Um, yeah, you can just think of like the how the angle would progress. You can, I guess you can also think of like each hour, for each hour there will be there would be two for each hour. There would be like one right angle clockwise and one right angle counterclockwise, and you would take two away because so that'll be 24, but you would take not 20. Uh, right, that would be what that's like 48, and then you would take away like the ones like Austin said, like at 3 o'clock. That one, at 3 o'clock. That's the how do I how do I put this? I don't know, but I guess you could just think of like what ones would be counted and not counted. I guess. Uh,
Um, yeah, I don't know. I don't know. It's kind of hard to explain, I feel like, but uh, I mean, if you have problems with this problem, just move on the test. But like when doing this problem, like just think about when they will cross to form a right angle, and you have to see that the right angle precesses, and the precession will cause the right angle to be missed on an hour. Uh, but yeah, okay. All right. Next problem. To create the figure shown, circle of radius 1 was drawn at stage 1. Two new circles of radius 1/2 were drawn at stage 2. Then 2 to the n minus 1 new circles of radius 1/2 to the n minus 1 were drawn at stage n. Each circle is tangent to one other circle of the same size as well as to one other circle of the next larger size. This process is repeated infinitely. The interior of each circle drawn at an on stage is shaded. The interior of each circle drawn at at an even stage is unshaded. What fraction of the largest circle is shaded? Express your answers as a common fraction. Okay, so it's basically just um, we have circles, and the radius is halving each time, but we're doubling the circles. So if you can see the biggest circle, we have one of them, and then the second set we have two half radius ones, and then the third set we have four circles that are a fourth of the radius of the largest one, and in every other circles we shade them. We want to find what's the shaded area, or what fraction of the largest circle is shaded. Um, so this one, it might seem complicated at first, but you can just make like an infinite geometric formula for the shaded area, and then when you sum it up, you can just uh, have it as a geometric series, and then you just use the geometric series sum formula. Um, so how you can do that is on the first stage, we're gonna have let's just say, wait, okay, it has a radius of 1. Okay, So it's gonna have a radius of 1, and we're gonna have one of them. So the area is just gonna be pi 1 squared. Okay. And then we're gonna need to subtract the area of the second set of circles. And then we're gonna add the area of the third set of circles. Then we're gonna subtract the area of the fourth set of circles, and we're gonna keep on doing that. Okay, so subtract the area of the second set of circles. So we have two of them, and then we're gonna need to multiply it by their individual areas, and it had have the radius, right? So like that. And then the third set, we have four of them, but they have a fourth of the radius. So it's going to be like that. And then the fourth set, we're going to have 8 of them. And they're going to have 1/8 of the radius. Okay, and then if I simplify this, you can see that we have what? Pi, and then minus 1/2 pi, and then plus 1/4 pi, and then minus 1/8 pi. Okay, so you can see that this series is geometric with a with a ratio of -1/2, right? So we're multiplying by -1/2, and this is going to go on forever. So then we can just sum this like a geometric series. So if you have an infinite geometric series and the ratio's magnitude is less than 1, which is the case here because our ratio is -1/2, then the sum of the sum of the geometric series is going to be the first term over 1 minus. Oh wait, no. Let me say the ratios are not a, and a is going to be my first term. Okay, sorry for that. Okay. So then the sum will be a over 1 minus r. So a is our starting. A is our initial number. So a is pi in this case. And then our r is -1/2. Okay. So this equates to pi over 3/2, which equals 2/3 pi. Okay, so then we get that our shaded area is 2/3 pi, and we want this fraction to the or this to we want this to the ratio of the area of the largest circle, and the area of the largest circle is just pi. So then our ratio is just 2/3. Should be your answer. Yeah, that's your answer. If you guys want me to derive the geometric series sum formula, then I can, just for you guys to see. But it's not that hard to derive or anything. Okay. Anything you want to say there, Bill?
Yeah, you can also kind of just think of this problem like not exactly. You don't have to like write out all the areas and stuff. So if you think about it, like the the four small circles inside of the two like blanks, if you move them all to one circle, that fills up the area of one circle, right? So if you think of that like pattern continued infinitely, it's basically just you're taking 1/4 out of every circle, basically. So it'll become you're taking out like what the sum of like the geometric sequence 1/4, 1/16, so on and so on. So you can also do it like that, I guess.
Uh, Wait, what is your method?
So like the circles, like let's just look at like the first three, okay? The big circle, the
Yeah.
two small circles, and then like the four circles, right?
Yeah.
So the four circles, you can actually move them into one of the circles, one of the like two circles, and that'll fill up that one circle, right?
Yeah.
And so now you're basically left with one big circle and then one small circle that's 1/4 the original size.
Now you're left with what? One big circle
Yeah, and then one
and
small circle that's 1/4 the size, right?
wait, what? Wait, sorry.
Oh, it's okay.
Wait, you said move the four third set onto one of the half on the second set?
Yes.
Okay, and then
So now
and,
you,
and then you have one circle with one half radius.
yes.
Okay.
And so now that you have that, if you if you look at each of the individual now if you look at the circles in the third set, if you keep going, they're
Wait,
basically the same thing,
y-
right?
yeah, you're saying for every site you can move uh like four of the circles into one of the circles. Uh,
Right.
so so then you're saying you just have like um
It's like a circle and then it's like one half radius and then it's another that's like 1/4 radius, another that's 1/8 radius. Is that right? Yeah.
I feel like that's harder for me to think about
Okay, I mean,
than just
okay. Uh,
than just than just listing the area. But I mean
and
if that
maybe
works for you, then
yeah.
you can do
There isn't this isn't like a very like one solution only. So if there's something else you're more comfortable with, you can use that.
that. Yeah.
This makes sense to me, I guess, visualizing it, but I don't know.
Yeah. Okay. Yeah, but generally with infinite sequence stuff, uh, you just want to try to like generalize the process into a series that you can calculate. Okay. Number 27. What is the sum of the values of x that satisfy 9 to the power of x cubed minus 3x squared minus 28x plus 60 equals 1? Okay. If we just think about 9 to what power equals 1, then the power must be 0, correct? Um, yeah, it has to be 0. Those are the only values of which 9 to the power of will equal 1. So then, because this is the power, we just want this to equal 0. And we want to find the sum of the x values that satisfy this. So basically, now we just want the sum of the roots of this polynomial. And guess what body formula we have for sum of the roots? It's Vieta's. So how we can do this with Vieta's is that the sum of the roots will be equal to the second smallest degree, second largest degree coefficient over the first largest degree coefficient times -1. So it's going to be -3/1 negative. So the sum of the roots is just going to be 3, and that's what it wants, right? So the answer should be just 3. um, yeah, Vieta's is what helpful. So um, again, if you don't have Vieta's, you should try to know Vieta's. Do you have a question, Ishan? Uh, 9 is 3 squared. That is correct. Oh, wait, what are you saying? Uh, well, yeah, I mean, okay, so if you, well, okay, yeah, well, yeah, if you have 2 times the equation that equals 0, you can just divide by 2 on both sides, right? So then you just have the equation equals 0. Yeah, okay, but also, it doesn't affect Vietas, right? Because you're gonna have 2 and -6, so you're just gonna cancel it out on the Vietas, so that also will just give you the answer. Okay, no, yeah, cool. Okay, next question. A right triangle ABC shown here, AC is 5 units, BC is 12. Points D and E lie on AB and BC respectively. So that CD is perpendicular to AB and E is the midpoint of BC. Segments AE and CD intersect at point F. What is the ratio of AF to FE? Express your answer as a common fraction. Okay. So we have a 5, 12, 13 triangle here. 5, 12, 13. And we have a perpendicular here. This is CD on the 13 side, and then we have a median here, AE, onto the CB side. Okay, and then we want to calculate the ratio of AF to FE. Now, me and Bill tried to solve this geometrically, but I think we didn't get to solve it geometrically, right?
No, we never ended up finding like.
Okay. Yeah, conclusion is we kind of suck at geometry, but this problem, I think the best way to do it would just be uh to coordinate bash, since what you can do is just find, so you find the coordinates of these points, and then you get the equations of the lines, and then you find the intersection of the lines, and that will be the coordinate of the point. And that's not too bad, I feel like. But if you're better with geometry, then yeah, you can try solving this with geometry. Um, but because I feel like I'm kind of bad at geometry, I would prefer coordinate bashing for this one. Okay. Okay, so for coordinate bashing, we just need to find the coordinates of these 4 points. So we can just set C to be the origin. So C is at 0, 0. Okay, and E is just the midpoint of CB. So it's going to be 6, 0. And then A is going to be 0, 5. Okay, and now we need to find D. That's going to take a little bit of work. So how we can find the coordinates of D is to find or we can find the length of segment CD, right? By doing like by finding area of the triangle in different ways with different heights and bases. So like the area of the triangle with this space or with this height and this base, it's just going to be equal to 30, right? But we also have a height of CD because it's perpendicular to AB and the base is AB. So then if we say, CD is X and we know AB is 13, and the area of the triangle is the same, we can say 1/2 X times 13 is still equal to the area of our triangle, which is 30. So then X will equal 60/13. So then we can get the length of CD. Okay, and then if we if we drop this line down, okay, yeah, this triangle is going to be similar to the larger ABC triangle. So this is because so let's label the angle at B with 1 tick mark and angle at A with 2 tick marks, and know that they're complements of each other, right? Okay. Now CDB, that's a right triangle, right? So then this angle at C is going to be the double angle because it's complement to the 1 tick angle, and then because this is double, then on our C, we can call this what? G. On our CGD triangle, this is also right. So we're also going to have this 1 tick angle here. So then this is just going to be similar to our larger ABC triangle. Okay, so and because this is these sides are parallel to our axes, these are also going to be the x and y values of our point D, which is what we want. And we found the value of the hypotenuse, so now we can just use it and use the ratios of the larger triangle to find these sides. So, okay, the ratio of our hypotenuse to our 1 tick leg, which is 5, is 13/5. And on our smaller triangle, this is going to be 60/13 over CG. So we should be able to solve for CG like this. So CG is going to be equal to 5/13 times 60/13, which is 169. Okay. Okay. And then now solve for GD. So that's going to be our hypotenuse ratio to our double angle side is going to be 13/12, and then on our smaller triangle, this is going to be 60/13 over DG. So then DG will be equal to 12/13 times 60/13, which is equal to 720, 169. Okay. Okay, so now we have the coordinates of all of our points. So now we can get the formulas for the line segments. So CD is going to be okay, it's going to have a slope of 720 over 169 over 300 over 169. So the over 169s cancel. We can cancel out a 10. We can also cancel out a 2 to get 36, 15. Cancel out a 3, 12/5. Okay, so that has slope 12/5, and that makes sense because this triangle was similar to our larger triangle, right? So you could just notice that earlier. So then it would just be 12/5. But yeah, okay. So then y equals 12/5 x, and then the y-intercept, we have to make it so that it satisfies this point. So basically, if we call our y-intercept c, then 12/5 of 300, 169 plus c has to equal 720, 169. So then c will equal 720, 169 minus 12/5 times 300, 169. And then so this is going to be minus 600 over 5 times 169, and then this left side is going to be 5 times 720, which is going to be 600. Wait. Oh no, I'm bad. Okay. No, okay. The y-intercept is just 0 because the line goes to the origin. Okay, my bad. So yeah, we didn't have to do that. Okay, so y is just 12/5 x. Okay, now find the equation of AE. So you have the points 6, 0, and 0, 5. So then we're gonna have a slope of -5 over 6, which is -5, 6. Okay, so then y equals -5, 6x. And then from here we can see that our y-intercept just has to be 5. Okay, so now we have y equals -5, 6x plus 5, and y equals 12. Let's find where it intersects. So just substitute y. So then we have 12 x is equal to -5, 6x plus 5. Okay, and then we have 72 plus 25 over 30x is equal to 5. And that is 97 over 30. Okay, so then x equals 30 over 97 times 5, which equals 150 over 97. Okay, wait, this is a 6. Okay, I think I did the math correct. Hopefully. Okay. So now we have x is 150 over 97. And to find the ratio, we can just use this x ratio over the x distance of FE, right? Because the ratio of their x distances is going to be the same as the ratio of their line segment lengths. So we know that like CF here is what we just got, which is what, 150 over 97. Okay, and we just want to put this in a ratio to FE. Now we know CE in total is 6 because E was the midpoint of CB. So then we can just say FE is 6 minus 150 over 97. And we need to calculate that. So it's going to be 582 minus 150 over 97, which is 432 over 97. Okay. So that is 432 over 97. Okay. So now we just do the ratio of this over that. So it's going to be 150 over 97 over 432 over 97, which is 150 over 432, which is 75 over 216. Can you cancel anything else? Yeah, you can cancel 3. So then we have 25, 7, 2. and then can't cancel out anything else. So then our answer is just 25 over 72. And that's the answer. Okay, so not the best numbers could have gotten there, but it was alright. Anything you want to say there, Bill?
Uh, there's probably a geometric way to do this. That's probably easier than what we did. We're just kind of bad at geometry, I guess. Um, if you really can't think of a way, I wouldn't spend that much time on a problem like we spent. Like how much we spent. Um, I mean, other than that, like what we did, just coordinate bashing. It's just bashing. There's not really anything to say.
Uh, yeah. Like if you're really good at geometry and you feel confident about doing a problem like this, then you can go for it. But for me, like coordinate bashing in this case is a like safer option because I pretty much know that I can get the right answer with it as long as I don't make mistakes. So then I can just work through it like that. And maybe I can maybe I can consider that coordinate passing on this problem will probably take like a little bit long because the numbers are not great. So maybe I would like kind of save this for the end if I have time. But yeah. Okay. Oh, number 29. Okay, yeah. So like we said, we kind of do suck at geometry. Um, so uh, we did this. We try to do it for quite a bit of time, and we also cannot find a solution to this. Um, we also don't have the score distributions for this 2013 year, so we aren't sure if this problem was actually really hard or if we were just missing something very big. Um, so I don't know, Lishan, do you want to have a try on it, or do you want us to show you what we tried to do but couldn't get it to work, or do you want to move on? Oh, did you hear us? So, number 29, we also couldn't figure it out. So, do you want to have a try on it, or do you just want to move on? Yeah, it had no solutions, but it has an answer. National still has solutions for some reason. Oh wow. No, okay. K is not
not
40.
40.
It is not
It's
symmetrical.
not symmetrical. If it was 40, this question would be, um, yeah, it's
Wait,
not 40.
I'm looking at some more score distribution stuff.
Mhm.
For 2016 Nationals, the maximum sprint score. So you get one point for every correct answer,
Yep.
and you have 30 problems. The max sprint score was 22.
Mm.
That seems really, really low.
Yeah.
Also, wow, the average is also pretty low everywhere. It's like tens and eights. Wow. For nationals, and I don't know. I mean, I guess can't say because I haven't competed, but I feel like you can get a decent amount of problems pretty easy. For 2013, the max spin score was 28. Oh, yeah, Lishan, we can't find the score distributions for this year. Um, yeah, I don't think I can find it. Uh, I can't seem to find it. Yeah, so we don't have the score distributions for this year either, so we can't really know if this problem was hard or not hard. Or we do know that at least one person got 28 on sprint. So, um, uh, yeah, we can't solve it either. So I don't know. Do you just want to move on? Okay, we could just move on. What?
Yeah, we're kind of bad at geometry.
What?
We're kind of bad at geometry.
Oh, or maybe it could be that the geometry problems in math counts nationals proportionately harder than the other problems, which could be the case, But I will say we are kind of bad at geometry. Okay, last problem. A triangle has sides of length 10, 17, and 21 units. What is the radius of its circumscribed circle? Express your answer as a common fraction. Okay, so the radius of the circumscribed circle, that's just the circumradius, right? And if you don't know all the all the circle stuff and radius stuff and like all the types of lines in a triangle, you usually get to know those, right? So like you have angle bisectors. Hold on, this isn't relating to the problem, but I'm just going to talk about it because it's pretty important. So or I'm just going to review it. So the angle bisectors are a line separating an angle into halves, and the angle bisectors of a triangle intersect to meet at the incenter, and the incenter is also the center of the circle that is inscribed within this triangle. Okay, and then you also have perpendicular bisectors. You also have you have medians, which you extend from each vertice to the midpoint of the opposite side, and these cross at one point, and the ratio of the vertice to the point length is always 2:1 to this rest of the line segment length. Okay, and then you also have just perpendicular lines like that from each vertice, and this is called the orthocenter. I'm not sure that has that many properties, but yeah. Okay, am I missing any? Oh wait, you also have perpendicular bisectors, right? So so yeah, those go through the midpoint of each side, and is also perpendicular. And then it's gonna cross at some point. And this point is the circumcenter, and it's also the center of the circumcircle of the triangle. So the triangle is inscribed in the circumcircle. And then the radius of this circumcircle is called the circumradius, and it's usually denoted with big R, and the in radius is usually denoted with small r. Okay. So if you don't know that stuff, then you should get to know it. Okay, and then for this problem, we're given 3 sides, and we want to find what big R is. And there are a few formulas for big R and small r, which we can use. So one is that the 3 sides of the triangle ABC multiplied together over 4 times circumradius is equal to the area of the triangle. So we have ABC in our problem. As long as we can get the area of the triangle, we can solve for the circumradius. And with the area of the triangle, we can solve it using Heron's formula. Heron's formula is that the area of a triangle is equal to the square root of the semiperimeter times semiperimeter minus one side times semiperimeter minus another side times semiperimeter minus another side. And the semiperimeter is just 1/2 of the perimeter. And the perimeter is 48. So then S is going to equal 24. So then A is going to equal square root of 24 times 14 times times 7 times 3. Okay, and then prime factorize this to look for factors to get out. So we're gonna have a 3 times 2 here and a 2 times 2. Okay, so you can take out a 2 here. You can take out a 3 here and a 2 here and a 7. So then our area is just this product, which is 6 times 14, which is 84. Okay, so then our area is just 84, right? So then we have ABC over 4A is equal to R. So then we have 10 times 17 times 21 over 4 times 84 is equal to the circumradius. And then now you just want to cancel factors on top and bottom. You can take out a 7 or 84. It was just 2 times 3 times 2 times 7. Take out a 7 from less than 21. Take out a 3 here. Take out a 2 like that. And then we have 85 over 8 is equal to circumradius. And that is our answer. You also have an equation with the in radius, and that is in radius times the semi-perimeter is also equal to the area of the triangle. You also have another one with circumradius, and it was like a or side A over sine of that angle A is equal to like is equal to R. It was that. No, it's 2R. But yeah, this is another formula for it. Yeah, it's A over sine A is equal to 2R. Okay, that can also be useful. Okay, anything you want to say there, Bill?
I mean, you covered pretty much everything I would have said, so I mean, yeah, there's nothing really I would say because you covered most of that.
All right. We can just move on to target now. Okay. Bobby saved $32 when he purchased a jacket at a clearance sale. If the clearance price was 40% less than the regular price, what was the regular price of the jacket? Okay, so he buys a jacket that is 40% less than the regular price and he saves 32, right? The amount he saves is going to be the amount that the jacket was reduced, right? And the amount the jacket was reduced was 40%. So if we say X is the value of the jacket, then 0.4 times X is equal to $32. So then X is $32 over 4 tenths. So $32 over 4 tenths. So 32 times 10 over 4. Cancel out 4 from 32 to get 8. So then you just have 8. And yeah, the answer is 80. The two cones in the diagram share a common apex and have parallel bases. Millie found the volumes of the smaller and larger cones to be 125 pi units cubed and 512 pi units cubed, respectively. She found the lateral surface area of the smaller cone to be 125 units squared. What is the lateral surface area of the larger cone? Okay, for this problem, you can use formulas and stuff and just solve for the radius and the height and a bunch of stuff like that. But there's actually a smarter way to do this problem, which is that if the volumes of the cones, well, okay, first look at the cones. They're like they're obviously what what they're obviously similar. Sorry, they're obviously similar, right? Because I mean like wait, how would you even say two cones are similar? I mean, okay, so like the point you can think of it as a uh uh wait, what is it called? Wait, Bill, what is it called when a point is the source of a dilation or
Origin? I don't know.
no, oh, homothety, or
That's
homothety.
a big
Wait,
word.
how do you
I don't know
pronounce
that word.
homothety? I need to know how to pronounce this. Oh crap! Oh crap! It's called homothety. Okay,
See, that sounds like something I've actually heard of before.
homothety. Oh, I thought it was homothety.
Homotheity.
Okay, homothety. Okay, okay, whatever. Okay, yeah. Okay, this point is a homothety, right? Because it's like you can scale the cones from this point, and then if you have two objects that are related by a homothety, then they must be similar, right? And yeah, and I mean you should be able to see that the sides of the cones are all just in the same ratio as to the larger cone. Like you can just see that with similar triangles and stuff. Okay. Okay, yeah. So the cones are similar, right? So then the smart way to do it is you can use the ratio of the volumes to find the ratio of the sides. And then once you find the ratio of the sides, you can square that to find the ratio of the areas. And like the lateral surface area is gonna go with the ratio of the side squared, right? Okay, so 125 is 5 cubed, and 512 is 8 cubed. So then, because this is volume, we can cube this ratio or cube root this ratio to find their ratio of size, right? So the ratio of volumes is 5 cubed over 8 cubed, and then cube root it to find the ratio of sides, which would be 5/8. So the larger or the smaller the smaller cone side length is 5/8 of the larger cone side length. And then we can just square this ratio to find the ratio of the lateral surface areas. So the ratio of the lateral surface areas is going to be 25 over 64. And because the area of the smaller cone is 125, then we multiply this by 64 over 25 to get, or this was our ratio. And then this will get the lateral surface area of our larger cone. So 125 over 25 is 5. And then this is equal to 320. That is our answer. Anything you want to say there, Bill?
So you can, so not only does this work on like, volume and area, also just like length and area when you're working with like length, area, length, volume, stuff like that. Anything with like dimensions, you're scaling it. Yeah.
Okay, yeah. But you also have to be careful to make sure that your objects are similar to each other. You can't just use it everywhere wildly. Okay. The set contains 4 integers. The sums of the integers in each of its 3 element subsets are 82, 88, 79, and 84. What is the median of the original set of 4 distinct integers? Okay, well, if our integers are like a, b, c, d, then we have like a plus b plus c equals 82, and b plus c plus d is 80. And it doesn't matter which set of 3 I use here, as long as they're different, right? Because like this is just a general set of, we don't care about order anyway. So then we can have like b plus c plus a is 79, and a plus no, I'm bad. Wait. No. Okay, we can have b plus a plus d is 79, and a plus c plus d is 84. Okay. And then this is just going to be a system of 4 equations, and you have 4 variables, right? So then you can just solve it like that. And the easiest way to solve this is just to add all these equations together. So then on the left side, you're gonna get 3 times a plus b plus c plus d. And then on the right side, you're gonna have to sum that. So you get what, 170 plus 79 plus 84. So that is 163 plus 170. So then that is 3, 3, 3. Yes, 3, 3, 3. Okay. Okay, this is equal to 3, 3, 3. So then a plus b plus c plus d is equal to 1, 1, 1. And then you can use a plus b plus c plus d to find each of the values of a, b, and c, because each of these were the sum of 3 variables, right? And this is the sum of 4 variables. So you can just do this, subtract one of these, and you'll get the variable that is missing. So now we can just find all the integers by subtracting each of these. So 111 minus 82, you're gonna have 29, and then this is gonna be 6 less, so 23, and then 79 is gonna be 3 more, so 32. 34 is gonna be 2 more, so 30. Wait, it's gonna be 27. Okay, so these are your numbers. So now you just need to find the median. So it's just going to be the average of the middle 2 numbers, which is 29 and 27, and then it's equals 28. This is our answer. Anything you want to say there, Bill?
No, I think we're fine.
All right. Pentagon ABCDE has AE equals AB equals 1 unit. Angles B and E each have measure 90 degrees, and angle A is 120 degrees. The 2 remaining angles are congruent to each other, and the 3 remaining sides are congruent to each other. What is the area of pentagon ABCDE? Express your answer as a common fraction in simplest radical form. So you have a pentagon like this. A is 120 degrees, E and B are 90 degrees, and D and C are equal angles, and ED, DC, and CB are all the same length. Okay, and AE and AB are both 1. So it's like boom. Okay, so these are 1, and these are all x. Okay, we want to find the area of this pentagon. Now I bet there are a lot of ways to do this. You can separate this into a lot of stuff. The way I'm gonna do it is I'm gonna put a parallel line through EB that is parallel to GC, and now we just find the areas of this triangle and this quadrilateral. The area of this triangle is just gonna be 1/2 AB sine theta. If you didn't know that formula, you could also just drop this height down. And because this pentagon is symmetrical, you're gonna have 60 degrees on this side, and then you just solve for these sides and stuff. And yeah, okay. But 1/2 AB sine theta is slightly faster. So then we have 1/2 sine of 120. And sine of 120 is just equal to sine of 60, right? If you think on the unit circle, this is 60 degrees. And then this is going to be 120 degrees. And it's going to go to the same sine value. And this is because they're both 30 degrees from the y-axis. So then sine of 120 is just sine of 60. The sine of 60 is just root 3 over 2. So then this triangle area is just root 3 over 4. Okay, now we just need to find this this quadrilateral sorry, now we just need to find this quadrilateral area. And from this triangle right here, we can see that this angle will have to be 30 degrees, right? So then this angle will have to be 60 degrees. And for this quadrilateral, you can also do this in multiple ways. One way you can do it is you can solve for this EB side by just doing the 60, 30, 60, 90 triangles. So from this triangle, you're going to have that this side is root 3 over 2. So then the whole EB side is root 3. Okay, and one way you can do it is you can separate the quadrilateral into two 30, 60, 90 triangles here and a rectangle in the middle. So then these small sides right here, these are going to be x over 2 because of the 30, 60, 90 right here. And this also x over 2 because of symmetry. And then this, you can just drop x up to here, right? So then you have x over 2 plus x over 2 equals root 3. So you can solve for x like this. So then you have 2x equals root 3, or x equals root 3 over 2. So now that you have x, now you can just find the area. One way you can do it is by looking at the trapezoid. Right, we had EB as parallel to DC. So you just use those at the bases, and the height is just going to be x over 2 times root 3. Again, from the 30, 60, 90 right here. So then our area is going to be 1/2 of root 3 plus root 3 over 2, because those are our bases, times our height. Our height is x over 2 times root 3. And x over 2 times root 3 is just going to be 3 over 4. Okay, and then this is going to be equal to 3/8 times 3 root 3 over 2. And then this is equal to 9 root 3 over 16. So this is the area of a quadrilateral, and area of a triangle was root 3 over 4. So you just add those two together. So this is 4 root 3 over 16. So then we have 13 root 3 over 16. That is our answer. Again, there are a lot of ways to find the pentagon here. Like another way you could have done it is like separated these into 3 equilateral triangles. Yeah. Okay, anything you want to say there, Paul?
Right. Like, and you And yeah, there isn't like one like steady way to do this. Also, you can probably split this up into like another different thing, maybe. I'm not sure, but
There's probably a lot of ways
yeah,
to
there's probably
separate.
a lot of ways you can split this up. Maybe like connect AD and AC. That could be a way.
Yeah. Also, drop a down and you have cyclic electron rules. I don't
Yeah,
know.
yeah.
Also connect, I don't know, like DB and EC, but that's kind of weird.
Mm.
Okay.
Okay.
Yeah, a lot of ways to do this. Okay. Number 5. We know the following 5 facts about the numbers A, B, C, and D. What is the value of A plus B? We have those 5 facts. Okay, and we just want to look at the facts and see anything that we can observe and try to work towards finding the values of these numbers. And from the second and third fact, you can see that D has to be 0, right? You have B plus C equals to 0, and then you add D and it's still 0. So D has to be 0. Okay, so it's not a good start. And from 5, we know that C plus A has to be less than 0. Okay, so now we have AB equals 1, B plus C equals 0, BC equals -9. And the second and third equations, you can just use these two equations to solve for B and C. So, you can just say B is equal to -C, and then here you have -C squared is equal to -9, and then C squared is equal to 9. And you have to be careful here, because C squared is equal to 9, not C is equal to √9, then C can be equal to plus or minus 3. So be careful on that. Okay, so C is plus or minus 3. So then B is minus plus 3. Wait, do you actually say it like that? Minus plus? Or minus or plus?
I've always said plus minus. Uh,
No, but if it's
oh,
the
if it's like
opposite,
that,
yeah,
um, I've never
minus or
I've never
plus.
had to say it before, so I'm not sure. I guess
Yeah,
minus plus would like get the point across.
yeah. It sounds weird though. Plus or minus, minus or plus. I don't know. Okay. Uh, yeah, but you can denote B like this. So basically, it's also like plus or minus, but if you have it flipped like this, then it's always going to be the negative of whatever C is. Okay, and then okay, AB is equal to 1. So then A has to be equal to plus or minus 1/3, right? Because it has to have the opposite sign of B to equal a positive value, and it has to have magnitude of 1/3. Okay, and now we've used all of these equations, and the last thing that we haven't used is the C plus A is less than 0. And we can see here that C and A have the same sign, right? So if we want their sum to be negative, we have to have C and A to be negative. So C equals -3, A equals -1/3, and then B will then be positive 3. Okay, so then A plus B will be 3 minus 1/3, which is 8/3. Wait, did I do something wrong? Yeah, I did something wrong. Wait a minute. No, A will be the same sign as B. Um, it will be minus or plus, right? Because If it's the same sign, then it's always going to it's always going to make a positive, not a different sign. Like that. Okay, so then if C and A are different signs, and one has magnitude 3, one has magnitude 1/3, then the 1/3 has to be negative. No, sorry, the 3 has to be negative so that the sum is less than 0. So then C is -3, A is positive 1/3, and B is the same sign as A, so B is 3. So then we have 3 plus 1/3, which is 10/3. Okay, there we go. That is our answer. Anything you want to say there, Bill?
I mean, this problem, you were just deriving the equations. I don't think there's much to say about that.
Okay. Okay, next question. In rectangle ABCD shown here, points E and F lie on sides BC and CD respectively. Point F is the midpoint of CD, and BE equals 1/3 of BC. Segments AC and FE intersect at point P. What is the ratio of AP to BC? Express your answer as a common fraction. Okay, so F is the midpoint of CD. BE is 1/3 of BC, and these segments intersect at a point P. Now, realize that there's nothing constricting what the size of the rectangle has to be, right? Like, I can make the size of the rectangle anything. I can make the size of the rectangle anything, and then F and E are adjusted, and they're always gonna intersect P at some point, right? So, basically we can have the size of a rectangle to be anything we want, and then apparently the ratio of AP to BC will always be the same. So then we can set it to anything, and we just solve for that ratio. And a pretty good side to set the rectangle sides to is 3 and 4, with 4 on DC and 3 on BC. So that I mean, this is just so that your numbers are a little bit better. This is so that the FC will be 2 and BE will be 1, and then AC will also be an integer of 5. So let me go ahead and make that rectangle, label some stuff. Okay. So this is 1, this is 2, this is 2, this is 2, and then this is 5. And this is 2 and 2, right? And this is a right angle, so we can see that this will be a 45, 45, 90 triangle right here. And maybe you can do this with geometry. You probably can. But again, I think the safer method for me would just be to coordinate dash. So find the equations of these two lines and then find their intersection. Okay, and I can set my origin to be let's just go with the origin is at D. So then my point F is at 2, 0. Point E is at 4, 2. Point A is at okay, sorry, it's at 0, 3, and then C is at 4, 0. Okay. So now we can just find the equations of the lines. So just start with this line. So this line is going to be slope 2 over 2 or 1. Okay, that makes sense because it was 45, 45, 90. And So then it's going to have equation y equals x plus some constant. And then from 2, 0, the constant has to be -2. Then our second line, the slope is going to be -3 over 4, -3/4, y equals -3/4, times x plus some constant, and use for 0, then the constant has to be +3. Okay, now solve for the set. Just plug in y. Then we have 7/4 x is equal to 5. So then x is equal to 20 over 7. Okay. So then the x value of our p all the way here is 20 over 7. And we know that the full length of DC is 4. So then the x length of p to c is going to be 4 minus 27, which is 8/7. And again, you can find the ratio of length of AP to PC with the ratio of the length of their x segments, right? So then their ratio is just going to be 27 over 8/7, which is 20 over 8, which is 10 over 4, which is 5/2. That's our answer. Anything you want to say there, Bill?
Again, I think okay, so for this problem, like the nice part about this problem is just that you can manipulate the size to be whatever you want. Mm, right, like when you see problems that like doesn't specify some things, you should see what what can you change without losing generality. So like, well, not losing generality. Like what can you change and like still have the problem be right? So in this case, like the side length. And a lot of the times you can just change like the side length for like the rate you have to stay a certain ratio. Oh, this is special. You can change like the ratio of the sides and it still works. So I don't know. I guess these things can make doing the problem easier.
Yeah. Just notice that like you can make the size anything, and the problem is still like satisfied. Like there's nothing really restricting it. Oh, maybe you could also just have made the rectangle into a square. Maybe that would have been better, actually. Yeah, and then you can do it with geometry really easily. Yeah, that would have probably been better, actually. Okay. Oh, okay. So number 6 was the last problem that me and Bill got to. So now we'll just okay, see you, Lishan. But now we will just try and win the problems. Okay, we have what is the smallest possible value of the absolute value or of the sum absolute value of x minus 2 plus absolute value of x minus 4 plus absolute value of x minus 5. Okay, and x can be any real number. You can think of this like distances on a number line. So the absolute value of x minus 2 is the distance x is from 2. And same thing with the other numbers, so 2, 4, and 5. And you want to minimize the sum of their distances. And what you can do with that is just take an average of their points, right? So the average of these values will be the point where their distances are minimized. So then we just take the average of 2, 4, and 5, which is 11 thirds. Oh crap, I'm wrong. It's my bad. Wait, why is that not correct?
Oh, it's not correct. What was the answer?
3.
3? Huh.
Wait, okay. If you have 3, then it's 1, 2, and wait, what? 1, 1, and 2, right? So 4.
No.
And then
No,
above
no, no. The
what?
smallest value itself, right? So the value itself will be 3.
Oh, the value itself. Oh, not the x value.
Yeah.
Okay. So the x value should still be 11 thirds. Okay, so you're gonna have negative x's on the 4 and the 5. So you're gonna have negative x minus 2 plus 4 plus 5. So then, wait, what? Wait, no. Wait, no. Wait, what? See, okay, if your x is 11 thirds, then you're gonna have x minus 2 minus x plus 4 minus x plus 5. So then you have negative x plus 7. That's not right. Uh, why is this not right?
Hmm.
Would it not be the average?
Ooh. Okay. So I think x is 4, right? Yeah, x is 4. The smallest value. Okay, think about it this way, Austin. If x is 4, if you increase x, you're increasing the distance from 2
Yeah,
and 4 by 2 times. Well, you're only
yeah, I
decreasing the
get
distance
that.
to 5. If you decrease it, you're increasing the distance from 4 to 5, only decreasing it to 2. So it would
Yeah.
have to be a 4. X would have to be a 4.
So it's just not averages?
I guess not.
Why is that not? I feel like that's so weird.
Maybe it's because of the absolute value. I'm not sure. Actually,
Well, okay, well, I mean, we're just thinking of the sum of the
yeah.
distance. Hmm. Yeah, it's a little bit iffy, but yeah. So what you can do here is you can have like a point here. Think about sliding it left and right. And think about like how you can reduce the distances, right? So if I have a point here, I slide it left. I'm increasing the distance from 4 and 5 and decreasing the distance to 2. So I'm increasing 2 and decreasing 1. So that's obviously not good. If I move it to the right, though, I'm increasing 4 and 5 while decreasing 2. So I'm increasing, decreasing 4 and 5 while increasing 2. So I'm decreasing more than I am increasing. So it is good to move it right. Now, how far do I move it right? Well, once I move it to 4, then I don't want to move it right anymore, because if I move it right, then I am increasing 2 and 4 but decreasing 5, which is not good because I'm increasing 2 by decreasing 1. So then my optimal point is just at 4, and then at 4 you can see that the sum is smallest at 3. Okay. Um, what is the maximum possible area of a triangle with vertices A0, B0, and CD? Where what is that? Okay. 1 plus a minus 2a squared equals 1 plus b minus 2b squared equals 0. And 1 plus c minus 2c squared equals d, and d is greater than 0. Express here, it's just a cut fraction. Okay, well, I guess start by drawing the triangle. Oh, no, the vertices are, okay. Okay, so, this is at, this strong badly. Oops, okay. Okay, so basically, this is the origin. So this is A, then this is, this right here is, this is, what? C, and this D, and then this is B. And we have some wacky equations.
Okay. So, you can factor those as, 2a plus 1 and a minus 1. Wait, no.
What?
Yeah. 1 plus 2a and 1 minus 2a. Or 2a plus 1 minus 1 minus. It's just positive and negative, so it's fine. 2a plus 1 and a minus 1, right? And 2b plus 1 and b minus 1, right?
Wait. 2a should be.
It should be plus. Wait, why'd you put
Oh,
negative
no,
2a?
I'm bad. Wait, no, you had to have a negative 2a. No, I mean negative a. So,
Okay, yeah, negative a, and then you would, plus 1. I just took out the negative.
yeah.
I don't know why. And then same for b, and then same for the c thing. So,
Equals d.
so I mean, you could
Um.
just solve for different
That's
values of a, I guess.
Wait, what? Or you want the maximum possible area?
Yeah.
Um. Okay, well, is it isn't the area just 1/2 DC? Uh, no. Oh, Shoeless theorem, right? CD A0 B0. So you're gonna have negative AD and then BD, and that's it. BD minus AD over 2. This is what you need to maximize. Or D times B minus A. That's what you need to maximize. Also, you have A times 1 minus 2A is equal to B times 1 minus 2B.
Right.
So A can equal B. Is there anything else?
Um,
I mean, it's just A equals B, right? I mean, it's just like you have two parabolas and they're the same, so it's only A equals B, right? Or am I missing something?
oh, hang on. If you were to,
Wait, but that doesn't make sense, right? If you always have A equals B, then this is zero.
hold up.
What? Wait, did I do this wrong? Oh wait, it's at A0 and B0, not
Oh, oh,
zero
wow.
B.
Yeah, it's not a eight.
Oh, okay. So it's like that.
Yeah.
Um. Oh yeah. Okay. Yeah, the area is gonna be this. Wait, okay. So B does not always equal A. How does that work? Oh,
It
if
didn't
one of
say
these is
this
zero.
triangle has
No.
positive area.
Wait, what?
It didn't say this triangle has positive area. I'm just joking.
Oh, is it, you mean like it's zero? Okay.
It could be.
Okay. So A has to always equal B instead of or or except when these
Yeah.
opposites are zero, right? Okay. So then A equals one half,
Hmm.
B equals zero. Wait, but then isn't this just two cases? Or they're the same case, right? What?
Right,
Is
that would be the
this?
same case.
But
They'll
then
have to be.
isn't this just the area though?
The,
Then the area would be one half of D, and you just need to solve for D.
yeah. For D, C doesn't really matter, so you're just waiting for the maximum value D can be. It's like C
Oh yeah,
can,
you also want to maximize D, don't you?
because C, like, the C does not matter at all. So you have to look for the maximum value of D.
Hmm. How do you how do you do that though?
Find the maximum value of D?
Yeah, why can't D be infinite?
What?
Why can't D be infinite?
Because D has to satisfy 1 plus C minus 2C squared.
Oh, you just want to find
Yeah.
you want to find the maximum value of one plus C minus two C squared,
Yeah.
and C can be like anything, right?
Yeah. Because, it's
Okay.
parallel, you're just moving on the x-axis. So.
So then it's just what is that -1? So is that -2? What?
Wait, -1?
Okay, wait. -1 half.
-1 half? Wait,
What?
is it a -1 half?
Oh no, I'm so bad. No, okay, no. It's I for some reason use one as a
Wow.
because okay,
Wait,
whatever.
even if you use 1, then it still shouldn't be negative, right?
No?
Wait, am I
If you use
or am I
1,
dumb?
okay, just whatever. Okay, it's gonna be positive 1/4.
Yeah, see, it should be positive 1/4.
Yeah, okay. It's minus 2/16. Okay. Then what? 20 minus 2 is gonna be 18/16. Um yeah, and then 9/4. No, 9/8. Yep. Okay, and then just 9/16. Hopefully. No, it's not. Oh wait, no, wait. Okay, wait. It's gonna be a 1/4. Um, yeah, it's gonna be a 1/4. It's gonna be 5/4 minus 2/16, which is 20/16 minus 2/16, which is 18/16, which is 9/8.
Wow.
So then we have 9/16, but that's
Oh,
not correct.
oh boy.
Oh boy.
What is correct?
It's 27/32.
That seems awfully suspicious.
Kind of close to it, aren't we? Just need a 3/2 on it.
Now, where can the 3/2 comes from? Ah, ah, ah,
Uh, what?
um, 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 um. Let's see here. Let's see here. Let's see here.
Is it from our B and A?
Yeah,
I mean,
definitely
this
from our
D has
BA.
to be the maximum, right?
So what if A is no, hang on. Bum, bum, bottom, bum, bottom. Go back to the problem again.
Wait,
Let's go back to the problem. I want to see it again. Okay. 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 Oh wow. No, I think it's pretty obvious.
pretty
So
obvious.
remember when we factored the thing?
But they,
1 plus a minus 2a squared?
sure.
So that factored into 2a plus 1 and negative a plus 1, right?
Yeah.
So a can be a can be like negative 1/2 and b can be 1, right? And that still satisfies. The first thing is 0. 1 plus a minus 2a squared is 0. 1 plus b minus 2b squared is 0 if b equals 1, right?
Wait, but then is this thing satisfying?
If a equals negative 1/2
Um,
and
then
b
you have
equals 1,
1/2 times 2 equals no, -1. Wait, what? Wait, how does that? What? I'm so confused.
1 times negative 1. So that's negative 1 equals negative 1. So that works.
Yeah, it
Yay.
works. Wait, A. What? Okay, A equals -1/2,
Hmm.
and B equals.
That's, yeah.
Oh, no. It's because um, and B equals 1.
Yeah.
No, it's because okay, like they're this parabola, right?
Hmm.
So they can equal on um like opposite sides of the parabola,
Okay.
or they can be equal to each other on the same point, or or what? Or yeah, it's just wait, what? It it's just if they're opposite of the parabola, then they're equal. But to satisfy this, it's only like negative 1/2 of 1. I think. All right. Okay. So then this difference is 3/2. So then yeah. So then it should be 3/2 of 9. Wait, no, it's 1/2 of 3/2 of D, which is 9/8. So then, woohoo, we have 27/32. That's the answer. Let's go.
Woohoo.
All right. Okay, that's gonna be it for this math counts meeting. Thank you for watching, and you'll continue with 2013 Nationals team next week.